Hello everyone, and welcome to this webinar covering the physics concepts for the Science T-Level qualification. And while this webinar will be focusing on the Science T-Level, there will still be relevance for those of you who are delivering the Health or Healthcare Science T-Levels, due to the similarities in the specification layout and some identical physics content, etc. The plan for today's webinar is to begin with some brief introductions and our collaboration with STEM Learning. We will go through an overview of the specification and how the assessments will work. Then look at the physics content and the depth required. Look at suggestions for delivering the content, the resources and support that we have available to you, and finally, to address any questions you may have. However, please do ask questions throughout this webinar via the questions box, as I will be checking it throughout. But I would like to begin first off with just a little poll to gauge how confident you currently feel with the physics content, with 1 being little to no confidence and a 10 being extremely confident. So you should see that poll on your screen now, and I'll leave it on there just for a minute or so. Not many people going above 5 to 6, got like 70% in the 5 to 6, 20-ish in the 3 to 4. So quite a mix. Hopefully we'll be able to get you up to the 7s, 8s, 9s, 10s, maybe by the end of today's webinar. Okay, but first, just some quick introductions. And my name is David Kiernan, and I work in the provider development team at NCFE, and I look after the Health and Science T-Level route. And these webinars are part of a collaboration with STEM Learning, and we'll be working with them very closely, but one person in particular is Chris Carr, who is and these are the areas that will have an NCFE webinar with additional STEM learning sessions. And they will cover aspects such as prep to teach, general maths competencies, biology, chemistry, and the physics core concepts, like this physics webinar today, and health, safety, and environmental regulations. The STEM Learning website, the link shown there, contains further information. But we're going to begin with just a brief overview of the T-level and the assessments therein. For more comprehensive information, do please see one of our onboarding webinars. So what is a T-level? A T-level is a level 3 2-year program aimed at 16 to 19-year-olds. And they are equivalent in size, depth, and rigor to 3 A-levels, and they do attract UCAS points. T-levels themselves are owned by the Institute for Apprenticeships and Technical Education, or IFATE, and the design and content for the T-levels came from employer panels in the relevant industries. And because of these employer panels, T-levels offer students a route to paid employment. UCAS points are also available for the completion of a T-level, so students can progress onto higher education or onto a higher level apprenticeship. And the entire design of the T-levels is to ensure that students have the threshold competency for the relevant occupational role. The specification itself can be divided into 2 sections: the core content and the occupational specialism content. The core content, which is shown on screen, is further divided into 3 sections. Section A, working in the health and science sector. Section B, which is the scientific knowledge, concepts, and understanding of biology, chemistry, and physics. And the core skills. Now, this content will be common to all the Science T-level occupational specialisms. So no matter which occupational specialism students will be doing, they will be taught the same core content. And some of this core content is also root core content, meaning it will be common to the Health T-level and the Healthcare Science T-level too. And there are 3 occupational specialisms that can be delivered: laboratory sciences, food sciences, and metrology sciences. And there is one other part of the technical qualification that I want to highlight, which is the general competency framework. And this lists the English, maths, and digital skills competencies that students will also be taught. Again, the focus is for students to have the threshold competency for the job role, And these competencies are assessed, but they are also embedded within the specification. But it would be useful to develop these further with your students. The T-level assessments can be broken down into the core assessments and the occupational specialism assessments. The core assessments consist of 2 written exam papers covering the core content and an externally set skills assessment called an employer set project. It's called this as the tasks had input from employers to make them as realistic as possible. Then the occupational specialism is assessed in year 2 with externally set synoptic assignments, which are also designed to be as occupationally realistic as possible. We're now going to look at the physics knowledge and concepts that's within the science T-level, and we'll have a look at the content as well that is common to the health and healthcare science T-levels too. But first I would like to launch a poll, as I would just like to know which science occupational specialism you're going to be delivering, or if you're not delivering the science T-level, then which pathway is it you are delivering? Are you delivering health or healthcare science? And do please tick all of those that apply. Okay, we do have the majority of people on here delivering science, and it looks like laboratory sciences, definitely the majority people are doing, but we also have about 20% of the people here are also delivering health, so make sure to give some health suggestions as well as we go. I'm just going to close off that poll, and we're going to focus today on the physics content in section B of the specification. Now B1 has got 4 key physics headings as shown on this slide, and the B1 content, remember, is what's called root content. So everything in B1 also appears on the health T-level and the healthcare science T-level specifications as well. The science T-level has further physics concepts in B2, specifically gas laws and pressure, fluid, and viscosity content. And this B2 content isn't on the health T-level specification or on the healthcare science specification, although there is some medical physics content on the healthcare science B2. For the science T-level occupational specialisms, there is further physics within that part of the specification. I've just put a few examples on the screen there. So if a section of the core specification doesn't go into the depth you'd expect for a level 3 science qualification, then it's possible that that greater depth is actually within the occupational specialism content. Our focus for today, though, will be on the core content within B1 and B2. So what might be useful to begin with is determining what knowledge and understanding of physics students should have from GCSE. And this will help you to gauge expectations and develop initial assessments and activities prior to delivering the physics content. Now, do bear in mind, though, that students have had a disrupted year. We've had tags and CAGs, and so on. And so students will be coming to you with varying experiences, etc. So this GCSE content may not have been delivered to all students. And even without the world of tags and CAGs, etc., the amount of knowledge and understanding that students will have retained from GCSE can always vary anyways. So this is the GCSE teaching content and not a guaranteed list of students' knowledge. And in the handout section, you'll find this document that I'm going to put on screen, which you can download. And what it is a table containing the physics content on the science T-level, beside the relevant content from the GCSE combined science. So do want you to spend 5 minutes having a look, comparing them both, and do add any questions that you have or any comments to the question box. So on here we can see the B1 content for electricity, and from GCSE what the electricity content would have been, and so on for the rest. Spend a while just having a look what are some aspects that students would have been covered at GCSE. Okay, we'll begin by looking at the electricity content, and as you'll have noticed, some of this content will have been addressed at GCSE. Remember, the B1 content is root content, so health students would also be taught this. Those familiar with other level 3 science qualifications might expect to see content on bridge circuits, capacitors, oscilloscopes, etc. But this wouldn't be required for health students. Now, that's not to say you wouldn't teach those aspects at some point, but it may be present within the occupational specialism content rather than the core or root content. Now, I'm going to highlight a few things here which could be easily missed. Beginning careful reading of the specification requirements. Here, for example, you must teach students the definitions for current and charge and the calculation involved. Similarly, students need to know the definitions for current, resistance, and potential difference, and the Ohm's law calculation. So do take care with the specification to ensure all relevant content is taught. One more example is how best to read the specification to understand the depth required. And you can view the bold statement as the teaching that's required. In this case, students need to know the properties of mains electricity. To understand how much depth to go into about these properties, you should use the sub-bullet points. So in this case, students need to know that mains electricity is AC, so alternating current, 230 volt supply, and a frequency of 50 Hertz. When it comes to the magnetism content, students should have some knowledge on these aspects from GCSE and even Key Stage 3 on permanent magnets, magnetic poles, attraction and repulsion, magnetic field lines, etc. The aspects on the motor effect and the electromagnetic induction will probably be new to most students. So do read the specification in the same way though. So students need to know how a magnetic field is produced in a current carrying wire and the relationship between the magnetic field and the current carrying wire. And the depth required for that relationship are those sub-bullet points. With the wave section, students may not be aware of all the different examples and uses of waves, but they should have been taught about longitudinal and transverse waves, the wave equation, etc. When it comes to particles and radiation section, students should have been taught at GCSE about alpha, beta, and gamma and their properties, what half-life is, ionization, and some of the applications. So a bigger focus here might be on excitation and the electrons changing shells in B1.60, what count rate is, and all the different uses for radioactivity. Now the following content is applicable to the science T level only, and you may notice less content crossover with GCSE here. So students should have a qualitative understanding of pressure and temperature from GCSE, but the gas laws and equations might be new to students. This may also be true for absolute zero and the Kelvin temperature scale. And the final section, which again is only on the science T level, is the content related to pressure, fluids, and viscosity. Students should have an understanding of pressure and of density and the experiments related to density for regular and irregular solids. But again, most of the content on Newtonian and non-Newtonian fluids, flow rates, viscosity, etc. might be new to students. We're going to have a look at the delivery of this content and provide some suggestions too. And there are different aspects to consider with your delivery, such as ensuring students have the threshold competency for the occupational role. This would be worth keeping at the forefront of your mind. Setting the relevance for the content for food science students or health students. Ensuring students can apply their knowledge and understanding to various situations. embedding the core skills and developing further opportunities for the general competencies. And of course, ensuring students can succeed in their assessments and planning formative assessment opportunities. So ensuring students understand the purpose and the need for this physics knowledge can help actually with engagement. And it's probably easier to set the relevance for metrology and laboratory sciences, but food science students and those doing health and healthcare science may not see the relevance and why they need this physics understanding. And I do want to get your suggestions for how the relevance could be set for your students by this word cloud activity. So do add any suggestions you have for the relevance to this. Okay, so we can see we've got quite a few different suggestions in there. So talking about action potentials in neurons and electrosurgery exchange, reading results, pressure, safety, gas instrument use, partial pressure, so for lungs and so on, radionuclei used in nuclear medicine, medical physics, waves and medical treatments, medical imaging. Good, so lots of different suggestions on there. Thank you very much for those. And with that, I'm just going to put on a few suggestions of my own. I'm not going to spend too long on these, but I do want to highlight just a couple of examples for metrology sciences. So the magnetism and electromagnet element can be related to what's called the electronic kilogram, where the weight of a mass is balanced by the upwards force of an electromagnet. And the mass of the object is related to the electrical current flowing through the electromagnet. Terahertz metrology is examining the electromagnetic spectrum that lies between microwaves and the far infrared. T waves, as they are sometimes called, are non-ionizing and have the ability to cross many non-conducting materials, for example, paper, plastics, fabric, and organic tissues. They can be used for non-destructive analysis as well by spectroscopic measurements, and they can be applied in diverse areas as well, from biology to chemical, pharmaceutical, environmental science, etc. For food sciences, here's a few examples of where the relevance could be set, such as ohmic heat, which is based on the electrical resistance of food, where an alternating current is used and can ensure uniform, rapid heating with minimal heating of the product surroundings. Neocarbon food is the production of microbial protein using mainly electricity, water, and carbon dioxide, with production actually expected to begin around 2024. For the magnetism content, the use of magnetic filters to prevent metals falling into foods on a production line. For waves, we could talk about the use of infrared for heating and the use of ultrasounds for different purposes depending on the intensity. For radiation, there is the extending shelf life of products, and even discuss the natural radioactivity in foods, such as Brazil nuts, butter beans, bananas, etc. For gas laws, it can be around how gases change under different conditions when cooking. Using gases for preserving food, such as in crisp packets, and considering the pressure and volume needed, and the process of pressure cooking. And finally, for the pressure, fluid, and viscosity section, you could link the flow of different materials, such as the flow of sauces through tubes, getting the thickness correct, for example. And for anyone doing health or healthcare science, here's a few examples for the B1 physics content to help engage your students. So even briefly, just setting the scene can help. So just telling students that body fat analysis machines use electrical resistance. So we're going to learn a bit about electricity. For magnetism, there's different health devices and therapies that involve magnets or magnetic fields. Waves can be set in context to ultrasounds, X-rays, etc., that are used for diagnostics and treatments. Particles and radiation can link to medical tracers and even staff safety by wearing and measuring the level of exposure to radiation. Let's now look at some specifics with the delivery, and I want to hand over to you again. So some points to consider is teaching activities that you could do with your students. Could the physics content be reinforced in other areas of the specification? Can we embed some of the core skills and even the general competencies within the delivery too? So I'd post it to the Jamboard with your suggestions. I got lots of suggestions in here. Let's have a just quick read through them. So Lincoln B1 and B2 thought about the respiratory system and partial pressure. Okay, impact of higher altitudes. So I'm guessing this is a respiratory system. That would be either a health or healthcare science example. Good. Using the half-life graphs for maths, so doing some calculations of half-life graphs. Yep. Sound waves and hearing, acoustic wave to electrical energy within the middle and inner ear. Excellent. Rearranging equations, following measurements of circuits and looking at linking to maths competencies. Okay, so do some circuit measurements and changing around equations. Someone's Chromebook being a little bit funny. Wonders of technology, this does happen unfortunately. So a PET scan, so reactive glucose to identify cancer cells, going through mitosis, high energy, glucose use, good. Microscopic slides and sessions I taught, how electricity is passed and why these devices are important in the health sector. Gas laws and chromatography, oh yes, because there is the different types of chromatography, yep. Building circuits with resistors and seeing if the calculation matches the measurements, okay. Excellent, some great suggestions there. And here's some ideas for bringing section A into the physics content, which can help give students a holistic view and develop their threshold competency. And in the science T level, almost everything from A6 onwards could be brought into the physics, as the content is closely related to experimental procedures, data, equipment, etc. There's also some specific examples within section A, such as A4 with content on electromagnetic fields and regulations, working with ionizing radiation, etc. And A10 on some specific equipment and techniques that's more related to physics. For the core skills, here's a few suggestions for embedding them. So project management and making financial forecasts could involve giving students some costs for lengths of wire and for cost of electricity, and students are to decide whether it's better to use more wire or more current when making an electromagnet. Research could be around electromagnetic waves and some of the early concerns that were expressed over microwaves being used for mobile phone communications. For creativity and innovation, students may need to find a way of determining the volume for an irregular shaped solid in order to perform a density calculation. These are just a few quick examples, and they could include other aspects too, such as communicating, teamworking, problem solving, etc. To further embed the general maths, English, and digital competencies, here's some suggestions for including the physics. And these suggestions can also include multiple competencies and the core skills too. So for example, comparing UK mains electricity with other countries and writing a report on this can include core skills like researching, presenting, and as well as English and even digital competencies, depending on how they actually present their findings. A more recent example can be found around some of the social media claims that the COVID vaccination was causing people to be magnetized at the vaccination site. And this would also bring in researching skills too. There are plenty of examples of equations to be used in the physics content, but graphs could also be used here, such as half-life graphs, as was suggested by someone else. Maths competencies does include measuring with precision, so just the correct and careful use of various equipment could be useful here. Digital skills can be on presentations, leaflets, etc., explaining physics concepts, such as the motor effect, but also the use of spreadsheets for making tables, producing graphs, etc. such as making a trend line to find absolute zero from some gas law data. So we're going to finish off on the support and resources that we have available to you. Now I'm going to talk through the resources currently available and in development from NCFE and what some other third-party organizations are currently doing. Now our content team have developed and made available example schemes of work for the core content, as well as teaching resources to help with delivery. There are the essentials resources, which will be free, and additional resources available on a yearly license. These resources will contain an e-learning resource or presentation, activity sheets and/or home study sheets, which will be as interactive PDFs, and a session plan to accompany the e-learning resource. You may find other free resources on the health and healthcare science pages too that could be used in your delivery of science. And aside from our resources, Hodder are producing a textbook for the Science T level and also one for the Health T level, which will be due to be released very soon. STEM Learning have a T-level resources page. This page is broken up into Section A and Section B of the specification and contains links to various resources. There's also a section for the general maths competencies. And while the focus of this page will be for the Science T level, you will find content relevant to health and healthcare science too, since some of the content is shared, the root content. We have an interactive PDF for our upcoming events and webinars, the first page being shown on screen now, and has all the planned sessions for the duration of your T-level program delivery. Second page is now shown, and this breaks the support we offer into different types of pre-onboarding, onboarding, and further CPD, such as this event. We've included the link to this document and also the link to view all of our past webinars, as every session we delivered is recorded and you can find them on our YouTube channel. And this way centers can access those in their own time. STEM Learning has also got a CPD platform where you can search for upcoming sessions for the T level. Now you will need to register with STEM Learning first, and I've included the link to their main landing page where you can find the follow-up sessions that STEM Learning will be delivering. And this slide here provides information regarding the key contacts. The customer support team are probably going to be your first line of inquiry for things like registering students, using the portal, etc. As for me, I'm your contact for support related to teaching and learning and CPD sessions. And the account managers support centers as well with the business of delivering T levels. And our account executives and our centers do find having that singular point of contact very useful. And when it comes to contacting STEM Learning, there is an email address shown there for general inquiries, but I've also included Chris Carr's email address too. Now I do just want to finish off with the same poll question I asked at the very start. How confident do you feel now after attending this webinar with the physics content, with its delivery, depth, assessment, structure, etc. So I'll leave that poll on there just for about a minute or so, just to get the final responses in. Okay, so we have the answers in. Lots more people into the 7 to 8, even 20% into the 9 to 10, and we got about 75-ish percent in 7 to 8. And the remaining percent in 5 to 6. Okay, excellent. Thank you very much for that. I'll just close off that poll fully. Right, so most people does seem to have gone up in confidence, which is good. And I'm going to remain here. In case anyone has any final questions, then do please get them into the question box. I will be remaining on here for the last 5 minutes or so to address any final questions that you may have. However, if you don't have any questions, then I would like to thank you very much for attending today. And do feel free to leave, but I would appreciate if you would complete the little evaluation that's going to pop up when you do leave. Your feedback is absolutely vital to us. It's just 5 multiple choice questions, and then there's an extra box in case you want to make any further comments. And if you are leaving now, then from everyone here at NCFE, we want to wish you a very safe and successful year.